On this part of math, we are going to understand what is domain, and you're going to get the idea also of what is range, and you're going to take examples for the cases of the domain. Okay, as you know here, as you see, we have here y axis and here is x axis. Get horizontal and vertical lines. If I have now a graph, for example, the graph is going from this point, going this way, and stop at this point. For example, I have this graph as you see, and I'm asking you now, what is the domain and what is the range? What is domain and what is what? Range. Okay, the domain of any graph, it represents the value of x that participated in drawing that graph. Get in graphing that curve also. In other words, okay, what is the range? Range are the values of y that worked or that helped in graphing that curve. How does that happen here now for this graph? If I want to find, always when I find the domain, I go on the x-axis from left to right to see which is the first point of the left side of x that started participating in this graph. Then what is the last point of x of this graph? Okay, if I move now, imagine now I'm moving from the left. You see here now, I'm moving from the left. And I'm moving on x-axis. For example, here now on x-axis, I'm on -7. On -7 now on x. Is there any graph on this point now? No. So I continue here till I touch the first point of what? Of the graph. As you see now, I'm touching the first point where, when I'm touching the first point, what is the value of x there? As you see, the value of x there is what? Is -5. So this is now the beginning. This is now the beginning. Good. Now I continue here. I continue moving here till the last. I'm moving, as you see, I'm moving from the left to the right when I'm finding the domain. Good. I keep moving here to the last point. Where is the last point here? This is the last point. So the last point is when x equals what? As you see, it is when x equals what? 7. So that means the domain now is from, as you see, from point -5. And -5 here, as you see, the point is closed. That means it is inside the domain. That means it is included. So you put like bracket, not parenthesis. Then comma, then you write the final point of x, which is what? Which is 7 here. Then the 7 also, it is what? Included. Okay, what about if I have this point open? If this point is open, that means the -5 is not included. Just I write the same interval, but instead of using brackets, I can use what? Parentheses like this. So parentheses like this, it means -5 is not included in the domain. But here, if I use bracket, that means in this case, the -5 is included. So you understand now how to understand or how to find the domain of a graph. Okay, what about the range? The range is the same way, but in the range, instead of moving from left to right, just I move what? Up and down. Okay, now we're gonna understand how can we find the range. To find the range now, we go from the bottom, then we go what? Up. Now, if I'm moving, as you see up here, look, I'm moving now on the y-axis, and I want to see what is the first point that the graph is drawn on the y. So as you see, I'm starting from what? From -4 on the y. So that means this is now the first point on the y-axis, which is what? -4. Good. I continue now till I move to the last what? Point. As you see, I continue here. I continue here. Okay, when I move here now, is this one is the last point of the y? No, because I still have a graph above that point. So I moved to the last point. As you see, it is on what value on y? As you see, it is on the value of y. That is what? It is on the y value that is, just I move it back as it was. Okay. As you see, it is the point that is exactly on what? On 2. So I draw here 2 as the final point of the y. So that means here the highest point is 2 and the minimum point is -4. So in this case, I draw the range that starts from the least point, which is -4, till the highest point, that is what? That is 2, and both of them included, the -4 and the 2 are included, so you put them in a bracket. If one of them is not included, that means it's open there. I write it in a parenthesis. So this is the idea. So what is the idea now of domain? Domain are the values of x for any graph that participated in that graph. So you go to see from the left to the right, what are these values? If it is for the y, just it's the same thing. I go on the y-axis from the bottom, then I go up to find that range. So we understand now what is the range and what is the domain as an idea. But all the questions now, for the questions that will come to me now here, will these questions, will they give us the graphs and all the questions? No, in some questions they will not. We're going to take examples here. For example, here now they give us f of x equals x power 3 plus x squared plus 3x plus 1. And they ask me here, what is the domain? Now we're going to take examples for the domain. Okay, what is the domain of this function? As you see, if the function is polynomial like x has all of its powers that are what? Positive, and there is no fractions here. That means x is not in the denominator, and x is not inside a root like a square or cubic, and x has no power that is negative, so this one we call it what? Polynomial. So any function that is polynomial, its domain is always what? All real numbers, and we need to memorize that. Okay, what about if I have now f of x equals as a quotient x plus 3 over x minus 1. In this case now, this is a quotient function. If it is a quotient function now, the domain will be all real numbers except the numbers that they can make the denominator 0. That means the numbers that make the denominator 0, I cannot put them as values of x. I cannot use them as values of x. Why? Because they will give us no value for y. Again, the domain are the values of x that they can be used to find you a value of y. But if here now you put an x1, 1 minus 1 is 0. So, and up it's going to be 1 plus 4 is 4. So that means it's going to be 4 over 0. 4 over 0, will it give us a value for y? No value for y. So that means x is excluded from the domain. So in this case now, the domain will be all real numbers except, rewrite it as minus, the numbers that make the denominator 0. What number that make the denominator 0 here? It is 1. So that means r except 1. How I know the number that is a equals 0, make the denominator 0? I just put minus 1 equals 0, then I send 1 there, so that means x equals 1. So I mean this one now, when x is 1, is excluded from what? From the domain. Okay, when I have now f of x equals is square root of x plus 3. In this case now, what values I can put them for x? Look, any value can work for x. Any value from all the real numbers can work for the x here inside the square root, except the value that will make the number inside the square root as negative number, because we didn't have a square root of negative number. So that means what is inside the square root here has to be, so that means x plus 3, I need to make sure that it is greater or equal to what? 0. If it equals 0, it's okay, but it has to be greater or equal 0. So in this case, I send 3 to the other side. That means x will be greater or equal than what? -3. So in this case, now the domain is go from -3 into positive what? Infinity. And here it is bracket from the -3, because -3 is included, and since we have here equals, so you put it what as bracket. Okay, what about if I have now this one in the denominator? That means I have x equals 3x plus 2 over a square root here of x minus 3. In this case now, the denominator is a square root. And if it is a square root, by the way, what is inside the square root here has to be greater exactly than 0. That means it cannot be 0. If it is 0, the denominator will be 0. So that means if I have a square root in the numerator, what is inside the square root has to be greater or equal to 0. But if the square root is in the denominator, what is inside the square root has to be greater exactly than 0. So that means x minus 3, it has to be greater than 0. Send the 3 there. So that means x has to be greater exactly than what? Than 3. So that means now in this case, the domain will be 3 and positive infinity. And here it is what? Parentheses, and here parentheses, and parentheses. Here it means the 3 is not included in the domain. Because if the 3 included here in the domain, if you put it 3 minus 3 is 0, and the square root of 0 is 0, the denominator will be what? 0. In this case, it will not work. I hope that is clear. It related to the y equals absolute value of x. As you know, this is a parent function, and its graph is like this, and always whatever you put transformation for this equation, the domain will remain x, which is all real numbers. Okay, if I have now f of x equals the square root of x plus 3, and here x minus 5. Okay, how can I find the domain here? To find the domain here, I need to study now the numerator and the denominator. I need to study the domain of both of them as separate questions. Okay, to study the domain of the numerator, we put in what is inside the square root, which is x plus 3, has to be greater or equal than 0. So in this case, x will be greater or equal. When you put 3 to the other side, it's going to be what? X has to be greater or equal to what? To negative 3. Good. And what now, when we go to study now the denominator here, this one can't be 0. So x minus 5 equals 0. Just to know what numbers we make it, that means we're going to see that x equals 5. So x equals 5 is the value of x that makes the denominator 0. So this will exclude it from the domain. So now, if we see this domain now, we write it as interval. It's going to be negative 3 and closed here, as you see, brackets, and positive what? Infinity. But here now, x equals 5. So that means the domain of the numerator can be from negative 3 to positive infinity. If you make the number line, this is 0, and here negative 1, negative 2, negative 3, and here is, as you see, 1, and here is 2, and here is positive infinity, here is negative infinity. Good. So you're going to see here, this domain goes from negative 3, where it is closed, then to positive infinity. So this is the domain. But now this domain now, will it work with the denominator? Because the x value has to be the same number for numerator and denominator. And here for the denominator, as we notice, all real numbers except what? Except 5. So that means 5 is not included in the domain. I go to see where is 5 here. Is it here? Yes, 5. It's going to be 3, 4, 5. So 5 is here. So this 5 now, I have to exclude it from the domain. So the domain will be from negative 3 to positive infinity. The domain will be from negative 3 to positive infinity. That means any number in this interval except 5. Except what? Except 5. It cannot be what? It cannot be in that domain. So we understand now what are the cases of the domain. We'll have more examples on the next quiz. I hope now you understand it and try to solve them by yourself. Otherwise, you will watch the videos related. Thank you so much. See you in other videos.